Right, thanks so much for coming, everyone. My name's Ian Cooper, and today what I'd like to talk to you about is creating a renaissance around .NET development. Some of you may have seen me speak before. The only interesting point in that whole bio is the one on the bottom, and that's that I'm not, no one standing here is smarter than you, right? We have had the confidence to get up and talk. You are just as smart as us, I promise you, and please feel encouraged to do what I do here and get up yourself and speak at events and conferences. The greater the range of voices we have, the better. So where I work, I don't care about that apart from the fact that I have nothing to sell you. We're not a consultancy, we ship software. Okay, I'm going to talk today about where I think we are in .NET land, where I think the state of play is. I think we're in a bit of a decline. I want to talk about why I think there's a bit of a decline, and I want to talk about how I think we can have a renaissance that gets us out of that particular decline and reinvigorates both the platform and the community. I'd be very grateful if people would take this to a discussion on social media. Some of you may have seen I did a blog post a while back about some of these ideas and some of the problems that we're facing. And I think this is something I'd like to see the community engage with more widely. So anyone wants to tweet, I'm iCooper, by the way, that's my Twitter handle. But I'd be very grateful if anyone wants to tweet at all during this particular presentation about ideas they find interesting. And if you disagree, you might really disagree with what I'm saying, and that's all part of the debate. I want to kickstart a debate rather than necessarily say I am right. Okay. So what is a .NET Renaissance? Why might we need one? Okay. This guy here is basically Bob Lee, and in 2011 at OSCon, he said, we are on the cusp of a Java renaissance. And what he was basically the CTO at Square at the time, and he was alluding to the fact that there had been a significant fall in the number of people using the JVM to build particularly websites. And the reason was Rails. Rails had come along and was an exceptionally productive environment for people to work with. And as a result, people just stopped using the JVM to do it. I mean, at the time, remember, the JVM is enterprise Java beans, that kind of thing, and it's not really a productive environment. And Bob's point was, though, that there have been a number of changes. People have begun to work on new ideas. Netty is one of the ones he calls out. And at the same time, people were beginning to find, the Twitter story is quite famous, Twitter fail whales, that Rails wasn't scaling for them. And so there was a return to the JVM as a platform that could meet the scaling needs of these successful sites. And he called this the Java Renaissance. And I'd like to argue that we are in a similar position today, that we are seeing a decline in the use particularly of ASP.NET, and that we need to look for what will give us a similar renaissance in .NET today. I will talk a lot when I talk about the evidence for this about C#. And the reason, simply as Mads points out, is that we are several orders of magnitude greater in the number of developers on that platform. Equally, though, when we talk about the future of the platform, a rising tide lifts all boats. So we are obviously involving ourselves in raising Visual Basic and F# at the same time. Okay. So this is some data from Indeed.com, which is a US job site. And what it's showing here is oops, I got another slide. Oh, that's interesting. Okay, I can do this slide. This is showing basically the difference between Python and C# job postings in the US between 2012 and 2016. And you can see that the orange line, which is basically C#, declines from about 1.4 to about 0.89%. It's not quite a 50% reduction in jobs in the US, but it is of that order. You might say, oh, well, maybe there were just less computing jobs, recession, that kind of thing, etc. But if you see Python at the same period of time, is growing from about 0.5 up to just over basically 1. And effectively now, this is indicating that there are more Python vacancies in the US than there are essentially C# vacancies. So there's a pattern of decline that the US job data is indicating to us. This is UK job data. Now, the UK is very interesting because by a significant number of measures, C# is more popular in the UK than Java, and has been for some time. And that's primarily probably due to the influence of the finance sector. And languages are regional. You'll find C# sent to clusters in Seattle, Austin, London, places like that, etc. So it's a good bellwether, right? And you can see here that effectively, although that the permanent jobs have bubbled between somewhere around peak of 35% in 2013, they've fallen by about 5% at the minute over the last sort of 5 years or so from that peak. And contract jobs have been declining slightly earlier, but they've fallen from about 25 to about 18%, so a slightly bigger decline. The trouble, of course, with C# and talking about C# jobs is, C# includes both, let's say, the desktop environment where Windows is still preeminent, where there are not really many contenders against things like WPF for writing essentially your code. So it's more interesting potentially to talk about areas where there's greater competition, and that would be on the server. So we can look at numbers for ASP.NET. If you look at the numbers for ASP.NET, you can see that the top line, which is permanent jobs, again, peaked around 2012, around 27% of UK development jobs essentially were C#, but it's now at about 23. So a decline of 3 or 4% there. But what's particularly interesting to me is the bottom line, which is contract jobs. There was a huge crash around the time of the financial crash in terms of those jobs. But what's interesting is they never recovered. They never came back to C#. Since about 2012, we've fallen from about 15% to something like 9%. And this matches a lot with my anecdotal understanding of the jobs market in the UK. Although I'm not a contractor, lots of people I know are ASP.NET contractors, and they say they're finding increasingly difficult to find decent ASP.NET contracts. Most of them are really maintenance work. They're not seeing new projects. And that's a very kind of interesting proposition because in the UK, certainly, there is an overall pattern, which is many enterprises hire contractors when they are building new projects to help get up to speed and tend to use permanent staff for business as usual. Given that we know there must be, due to the peak of C# in the UK, a huge amount of existing code out there that's going to have to be maintained for years, we would expect to see the early signs of decline in the contract market where we see new projects tailing off. And I'd argue that there's reasonable evidence that we've been in decline, particularly as a server-side platform, since about 2012. And certainly I joined Huddle in, I think, about 2011, 2012. And at the time, there was a cluster of UK startups under Microsoft's BizSpark program, all using C#. Us, Just Eat, Just Giving, and a few other platforms around that essentially were quite popular. A few payday loan banks like Wonga, etc. And there's a real splurge of activity, but more recently I don't see the same number of startups actually engaging with ASP.NET as an actual platform to be using when they come out the gate. So overall, there's this kind of, what's happening? Why are we declining like this? Okay. So I think one of the first questions we ought to ask is, if people have left the platform, where have they gone? Because by understanding where they've gone, we may be able to understand what the threats are to the platform and how we actually fix that problem. This is from the Stack Overflow developer hiring landscape information, which you can download. This is the global numbers. There are more specific country ones, but I think the global ones tell the story well enough. So if you look on the left-hand side, you'll see essentially languages people are effectively working in. And I've drawn a line about 10%. So the languages that have more than about 10% market share, and they'd be the ones you'd kind of expect, right? C#, Python, Java, PHP, SQL, and JavaScript. And then down below are some ones that effectively are contending for that space. And the most wanted languages, the things developers want to work in, the big additions are things like Go, TypeScript, Swift, and Ruby, right? Those are the languages that developers say there are less jobs, essentially, than they want there to be in. Right. So there's definitely a movement there in terms of direction. Okay. This is from O'Reilly. And this is their web developer survey, and this kind of shows you what technologies are being used by web developers today. And you can see that ASP.NET's about 17%. C# is 2%. I imagine what that is people working in things like Nancy as a separate line item, or just confusion when they're filling in the form. But if you add those two together, C# is about 90%. It's behind Python and Java. It's way behind things like PHP, and certainly behind JavaScript. Okay. So let's have a look at some of these languages and see what's happened to them in recent years. So this is JavaScript jobs in the UK. Most of us are aware of the inexorable climb of JavaScript, but there is some evidence for you. Essentially, really, JavaScript takes off somewhere around 2010, 2011, and has been climbing ever since. you may say, well, that's just front-end jobs, people doing Angular, Ian. It doesn't really affect guys doing ASP.NET. But this is basically, again, from Stack Overflow, and that indicates basically that back-end developers are now listing JavaScript as basically a primary tool that they're using. Okay, you can see C#'s position by comparison. It's a global number, so that's why it's slightly different from, say, the UK numbers you've seen earlier. Even if we change this graph and say, let's just focus on job adverts that explicitly mention Node.js on the back end, you can see that from about 2012, the same period we've identified as being the point at which we begin to see a decline in the ASP.NET market, Node.js takes off. And now climbs to something like around 9% of jobs. And it's essentially, you can roughly equate the loss in ASP.NET jobs to the rise in Node.js jobs. Obviously, the market may be growing or expanding, so some of those jobs could be entirely new jobs, etc. Okay. And when you look at, say, Stack Overflow again, and you look at what were the most popular technologies in 2013, Node.js is towards the bottom of this list, has a small number, and Angular is almost non-existent. So separated out from JavaScript itself, and C# is about 40. And you look in 2016, and you can see there Node.js has climbed dramatically, and as has Angular, and C# is amongst the fallers. Okay. So I think there's a pretty clear sort of evidence that Node.js is essentially dominating the server platform, web server platform space, and we have lost market share and developer interest to that platform. Interesting enough, this is Ryan. Who knows who Ryan is, by the way? Yeah, so Ryan's the guy that created Node.js. Interesting enough, on LinkedIn, only 21 people think that Ryan's any good at Node.js, which kind of demonstrates the value of LinkedIn as a hiring platform. Okay. Java, did people go to Java? Interestingly, Java is suffering similarly to us, right? So although Java starts globally, well in the US essentially at a higher watermark, just under 3% of US jobs, the trend line is very similar. This is a big, similar established language and it's falling. You can look at...
Does that include Android?
Good question whether it includes Android. We'll talk about the next slide. So John was asking if it includes Android. This shows UK jobs, and you can see that 2009, that data looks a little bit anomalous to me, but that's the period Bob was talking about when everyone left JVM for Rails. You can see some recovery in 2011, so it could be a renaissance, and you can see recently there's an uptick. The question about the uptick is, as John raises, whether or not that's Android, and that's quite likely that Android has at least reinvigorated Java in a reasonable way that we haven't necessarily had in the C# platform. Python has also climbed considerably. I do Python now as well as C#, so maybe I'm a bellwether of that particular experience. Yeah, you can see that this bubbling around 2012, but post-2012 there's a huge climb in Python development. You can see that even on Stack Overflow questions, this class can be a little bit hard to read, but the two lines trending up, the green and the orange lines, are essentially JavaScript and Python. The ones trending down are C# and Java. So there's a growth in both those languages, basically on Stack Overflow. More people asking questions. In other words, more people learning and trying to understand how to use those toolkits. Python's interesting because it's difficult to know whether that's a direct challenger, essentially, to something like ASP.NET via Django. Is that a direct challenger? Because a lot of the growth in Python could be about the fact that Python dominates people doing effectively math. Because it basically has huge libraries for doing scientific computation and dealing with data. And for many people, the growth of data science, machine learning has been a growth in interest in Python. Okay. PHP, not much to say about PHP. It emerged about 2010, it's remained pretty stable ever since. PHP has its sweet spot. Loads of developers work for Facebook, but in addition, there are things like Magento, so e-commerce platforms. It looks kind of hard to shift. It's bubbling along. I don't think people left ASP.NET to go to PHP. I think the two are just essentially alongside each other. Okay, we're at the also-rans around here. Scala and Ruby, they're both about 6%. I hear a lot of anecdotal people saying to me, everyone's going to do Scala, right? And Scala really benefited from Java's long, painful tea time with the soul between Java 7 and Java 8. Scala was doing something, and therefore there was interest in Scala. Whether Java 8 has stemmed that a little bit, I don't know, but there are also emergent players on the JVM like Kotlin. is an interesting one. But Scala is one of those languages where I know quite a few people who are interested in functional programming work in Scala because it's functional programming, but hate Scala as the worst example of functional programming. So I think the very conflicted development community, and Twitter flirted with Scala and then abandoned it. So Scala is one of those ones, I don't know whether it will really climb out of its position. Ruby, again, Ruby is actually quite interesting. In the UK, this number is actually it takes off quite late and climbs quite slowly. In the US, this number actually, Ruby takes off a lot earlier. Rails is an interesting one. People talk about Rails now suffering from Ruby suffering the monoculture Rails of DHH, and questioning whether or not it's in a position that was criticized in the .NET platform years ago as being very monocultural. The question used to be Ruby or Python, who's winning, and the answer really pretty clearly is Python. Okay, and what about the others? Well, there's kind of a long tail of things that are kind of emergent languages that the smart kids tell you about that they're playing with. So, Uncle Bob and Eric Evans are always playing with Clojure, and some of the smart kids in the .NET platform, Mark Seaman and people there are always playing with F#, and they're telling us how exciting and wonderful these languages are, but they don't capture a huge proportion of the job market today, right? These numbers essentially are below 1% of the UK job market by comparison to even in decline C-sharps in 10, 20% regions. So they're orders of magnitude below. So they are there, people love them, but they're not really dominant players in the marketplace. It's not that C-sharp has declined because everyone's now an F# developer. Swift and Go have accelerated rapidly and are doing, in a sense, much better at escaping this adoption curve than F# and Clojure are. Swift, obviously, because who wants to use Objective-C? And Go is very interesting. Go has really climbed, and I think some of that can be explained to the interest in things like Docker, Console, Terraform, those kind of languages written in Go. But the rest of it is it's very accessible for developers from a C background, Java, C# to go to. It's performant, it's fast, it fills a nice sweet spot. And definitely all the graphs you see will point to Go as being something that you should pay attention to as coming up as a language. So in conclusion, where did everyone go? I think the big contender is Node.js in terms of server-side losses. I think there's a small amount of drift out to Python, but I wonder whether actually people are doing Python as well as doing other languages. And there's a small amount of drift out, even small amount of drift out to Scala and say Rails. But the big thing is Node.js came along and it captured a huge amount of the server market. Okay. So why are we in the position we're in? I mean, why did things like Node.js take off? I think one of the key problems that our platform has traditionally had is essentially Linux. I'll show you a bigger version of this number. These are some numbers essentially out of Wikipedia. It's difficult to get consistent numbers, but the headline is this. 2/3 of servers basically are Linux and 1/3 of servers are Windows. Traditionally, the model works a bit like this for Windows. Windows used to really have a sweet spot in small and medium-sized businesses. So you're a company up to about 200 employees. You have a kind of data center on-premise, and the people that look after that data center are Windows people. And they look after the desktops, and they look after the servers, and they look after Exchange, and they look after the software that's been installed by the third-party company and phone up if something goes wrong. Okay. And that model was the dominant model for a long period of time, and it created a lot of Windows servers, which meant Windows was a great platform to deploy to if you were targeting small and medium-sized businesses. What happened was we've begun to shift towards SaaS model, software as a service. So you're running somewhere in a data center, in a colo, or in the cloud, and those businesses are dropping data centers away and actually just having desktops, and even Exchange is now moving to the cloud. And that is essentially hammering into Windows, because in the big data centers and the colos, what you really care about at scale is the ability to automate, the fact that you can SSH into basically a machine and deal with it, you can write scripting, and that has led, in a sense, to the resurgence of Linux, basically, on those platforms. And Linux has things like container technologies, etc. And Windows is constantly trying to play catch-up in those particular environments because it was built for a different kind of scenario. It was built to be very similar to the desktop, to have an ease of use for the guy who basically worked for the SMB that ran your Exchange, supported your Office installs, your local desktops, as well as the servers. And not running on Linux makes life difficult for .NET. Obviously, that's being fixed by .NET Core. The other real kind of threat that we have is that the OSS ecosystem in .NET for some time has been continually criticized as lacking. So this is Aaron Scott. Aaron wanted to build a distributed system in .NET, and he had to write most of it himself. And his experience, he's the guy behind, one of the guys behind Akka.NET, and his experience was that he couldn't find the building blocks he needed. Lots of projects in OSS, there were ideas people had, but they were all very unfinished because they didn't have much take-up or involvement, or they were just simply kind of articles on code project. And then by comparison to, say, the Java ecosystem, he struggled continually to find the kind of tools he needed. So he had to go and write, for example, libraries to talk to Cassandra. He had to write a high-performance TCP IP stack equivalent to Netty. There was no active framework, so he had to go and write Akka.NET, right? All these things were problems that he was encountering, and that kind of burden means it's just easier to go and use something else, right? One of the classic problems here a little bit is this notion that our OSS community has been a little bit weakened by the presence of Microsoft. So what happens is that this traditional model, someone goes away, Charlie Poole and James Newkirk create NUnit. It wins awards essentially as a piece of code, but Microsoft replaces it with MS Test. Some people port Hibernate, people like Ian, they work very hard on Hibernate. It's potentially an overpowered ORM for most people's uses, but it's very powerful, and it has had strong ideas at the time, like persistence ignorance inside it. Microsoft produces an entity framework. The original version has this weird double abstraction model out of the 1970s, but it essentially crushes in Hibernate. Hammett works on Monorail, which essentially is an MVC framework, effectively for .NET environment inspired by Rails. It's pretty successful, and then ASP.MVC comes out and crushes it. And this was a model which led to people being very unenthusiastic about writing OSS in .NET, because there was a feeling that if your project took off and became successful, Microsoft would simply just write their own version and release it, and your project, because it then was essentially drowned by the 500-pound gorilla in the room. Now, every developer looks at what Microsoft is doing, reads it. It's very hard to get your project noticed in the OSS space if you're not Microsoft, right? I work on an OSS project called Brighter. We have people who use it, but it's very hard for us to basically get traction globally, right? Unless I go to all the US conferences and speak about it, it's hard. So it's an uphill struggle as it is, and it doesn't help when Microsoft effectively crushes that innovation. Okay. Is it the language itself, right? Here's a question, is it C#? I don't think so. C#'s on the most loved list. It's not up there with things like F# and other languages. Basically, the developers are really saying these are the hot tools, Rust and Go. But it's a solid top 10 language alongside things like Python and Node.js, right, which it beats. I don't think people are leaving the platform because they don't like C#. Is it because everyone's moving to functional languages, right? All the smart kids do functional languages. The rest of us wander around going, I feel stupid. But the reality is, as we saw earlier from those graphs, that the numbers of positions in functional languages don't suggest that we are seeing a move away from platforms because they're not functional. And the rise of Go, which is not really a functional language, demonstrates that there is still a significant appetite for our languages. This is Roger again talking essentially on Twitter recently about the fact that Stack Overflow's numbers suggest that we are way past the peak of people asking questions about F# on Stack Overflow. Okay, we'll talk a little bit about how languages gain adoption in a second. So I think the thing to understand is that I see occasional attitude from people saying, C#'s in decline, people aren't interested in it, but F#, that's where the future is. That F# is not your reserve parachute on the platform. In order to save the platform, we have to save C#. You're not going to be able to save it by basically pulling the F# reserve parachute ripcord. Right, is it because it's a static language, not a dynamic language? I find this one really interesting because this is my career. I started as a Fox Pro developer, which is basically a dynamic language, very powerful tool. We had things like inline SQL, etc., long before effectively they emerged with things like LINQ. But we found that there was a number of problems. There's a weakly typed dynamic language, and you could do interesting things like completely changing the type of a value halfway through a loop, etc. And the bugs in that used to drive us all crazy. So crushed were we by dynamic languages and the bugs that occurred with them. We went all the way to C++ because we thought types, we love them, we want as much of them as we can possibly have. C++ proved unproductive, so I went to C#. And then nowadays I do a bit of Python as well, although admittedly I'd quite often use PEP484 as optional typing. Okay. And I have an opinion like this, which says, generally I think this thing is cyclical. What happens is that we start effectively by using our lovely static language. It's all computer sciencey. We're controlling types, we're building our domain model. Our compiler's giving us tons of information. And then someone goes, but it's so slow. I'm writing all my DI, all my IOC containers, my factories of factories, all these interfaces. I just want duck typing, right? It would be so much easier. It'd be so much faster. So they pick up Python or they pick up Ruby and use a dynamic language. And it goes great. They're really fast. And then their site explodes in size and they're have more people on board. And finding it's quite hard sometimes to figure out what the hell is the parameter is basically in this function signature supposed to be. I have to essentially, spelunk the code by working through it to find out what methods are called. Duck typing's great, but it'd be nice to know kind of what you want the duck to do in some fashion, right? And so in large enough code bases, it turns out to be really hard with the dynamic language to actually maintain it. So then everyone says, well, we're going to use a static language again next time, right? And this cycle goes around. And I think actually the cycle is even more complicated than that, is that sometimes when we use the static language, we say, this problem was still too hard to get under control with static languages. It's still too complex. So I want to be declarative. I'm going to write a DSL, right, was the old school way of doing this. Or nowadays, I'm going to move to a functional language with a strong type system like Haskell or F#. And then I get the problem that half my developers go, I don't understand what's actually going on. This DSL is hiding too much from me. Wow, this functional declaration, right? Anything back to dynamic. So I think it's just a cyclical thing of none of these things are a silver bullet, and everyone just gravitates between one and the other depending upon what the problem space they had last time. So I don't believe that being a static language per se is a problem for C#. Complexity. One of the problems of being an older platform is that we're a bit like a show like Game of Thrones, right? This is Game of Thrones. If you started watching Game of Thrones at the beginning of season 5 with no other knowledge about Game of Thrones, you'd find it quite confusing and hard to follow. If you pick up basically the .NET framework today and look at basically the BCL, it's quite hard to follow if you're a newbie, right? I've got a newbie on my team, and I had to explain to her what WCF was for the other day, right? We'd never used WCF anywhere, but since some of our older code. She looks at things and says, what is this .NET remoting library, Ian? Should I understand that? And it's kind of like, no, just leave that alone, right? And that's a problem. This big surface area that's there is essentially a barrier to entry. Whereas if I go and look at a new language, one of the attractions of new languages like Go is there's not much surface area. That's a problem too, right? But there's not many libraries. I feel like I could understand that language and I could grow with it. So unless essentially you have a kind of year zero and reset to say, well, these are the essentials, we can push these older stuff aside, it can be quite intimidating. Okay. Visual Studio is a fantastic IDE. Its multi-threading support is just absolutely brilliant, and you can be enormously productive in it. But there's a challenge to getting people to learn Visual Studio and learn essentially your language and framework at the same time. It's a barrier to new entry. The way people want to learn a language is download your language in your runtime and get their favorite text editor from Notepad or Vim or Sublime or even Code, right? And actually write some simple programs and build up complexity. They don't want, quite often when you're beginning to learn a new language, you don't want to have to learn the debugging tool. You're just going to write some statements to print stuff out and see what happens. And the problem is that Visual Studio and .NET have historically been quite coupled to each other, to the extent that we often find there are decisions being made about the language or runtime because of Visual Studio. And we need to kind of wean the community off Visual Studio, lovely as it is, as the kind of entry point. We need to be assured that the scenario of I download the language in the runtime and I just work in Notepad or whatever works for us. Community. Yes, the leaving .NET emails. There are many of them, Actually, if you go and search for any language, you can find leaving emails. I did this, I can't remember, I think it was like when Go came out, I found leaving.go emails. This was like 2 years ago. I'm sure there are leaving D emails even now, right? With people basically throwing a strop saying, D has jumped the shark, I can no longer work in it. Every language has these. And per se, they are not a problem, right? You should expect people to move on from the platform. But the question is whether they are indicative of a bigger problem. I think these kind of emails are problematic, right? I love Rob, but calling enterprise developers derpy and this whole attitude that C# developers are somehow lesser because they work in enterprise, Actually, enterprise developers are, I have been one in my time. They solve similar problems to everybody else. Their focus is a little different because the business keeps telling them they're a cost, and they need to basically reduce costs as much as possible, etc. They're not the core business often. But they have a different set of demands, which is essentially pragmatism, productivity, not just using the new thing because it's trendy, but actually solving real problems. But it does, I think, hint both those things at a danger for us. And that's the danger that essentially, a lot of .NET meetups, Dylan and I were talking about this the other day, Dylan, from the keynote, we're getting a bit old and white and male, and that's potentially a problem, right? Well, it is a problem, not only in terms of diversity, but in terms of new entrants, and in terms of it being an echo chamber. And there is genuinely a need for us to attract new people onto our platform, right, who will essentially give us new energy and give us new insights and new inspirations. And we need to avoid a monoculture, not necessarily a Microsoft monoculture, but a community monoculture, where effectively we don't say we want to hear new voices, we want to hear new opinions, we want to be challenged. The orthodoxy should be overturned, right? And people like me are a danger, right? You come to NDC and you see me every year, right? And that's a danger, right? Because I could be completely wrong. I probably am. And we need newer, younger voices coming up here and taking my spot and saying, I have great ideas, okay? Harold Wilson said, the ex-British Prime Minister, the only place that you can't admit change should be the cemetery. To be a living platform, we constantly have to effectively engage with disruption. Okay, so how do languages succeed, right? How will .NET Core succeed? Most of you have probably seen this. This is the hype cycle. And this talks essentially about the journey anything goes through towards mainstream. So there's this idea effectively that the hype builds up, everyone gets very excited about it. There's nothing this language can do. It's going to create peace in the Middle East and solve cancer. I can remember the Java hype cycle was quite excessive at one point. And then everyone crashes because it turns out it can't do all these things into trough disillusionment. Some languages die there, right? They never emerge from that trough. It turns out the expectation was too great and it doesn't really do anything. But if they survive, what happens is those enterprise developers, the pragmatists, the people trying to solve problems for their employers, say, this can actually do things for us that help. And they begin to adopt it. So trough disillusionment is about 5% of people, and then effectively you get more. I would guesstimate that's where a lot of our languages we care about are today, are in a hype cycle. I made this up. It could be quite wrong. But essentially, the mature languages, C++, C#, Java, you're going to see them right over towards the right. You're going to see the emergent players who are climbing in terms of numbers, Node, Python, etc., further down. And then essentially, you're into this kind of like the other side of the trough. .NET Core, I think, is probably past the top of its hype cycle because we're now in the trough of disillusionment about .NET Standard, Project JSON. This is natural. All languages go through this period, right? It's not a bad sign. It's just all of us going, but this doesn't really, it's not magic. Why is it not magic? Why do I have to work? Swift and Go obviously doing very well, etc., right? Kotlin, I expect, probably is the top of its hype cycle with recent announcements. And then lots of new people will come to Kotlin and they will start complaining. Right. .NET Core, numbers in the UK about that. It's a very weird number. I mean, it's just a guess number based on things that actually explicitly say, I want to hire .NET Core developers. That's kind of what you'd expect at this point, I think, in the cycle. This is the thing that's key, this thing called crossing the chasm. So this idea, effectively, that you get early adopters, and innovators who pick up nearly anything that comes along down the line, right? They're the guys that every NDC you'll see them talking about a new technology. It's Elm this year. No, I've abandoned my old Rails ways. I'm into Phoenix and Elixir now, right? And then you get the normal people, effectively, the normal enterprise devs, who essentially are in the early majority, the people who say, well, hang on a minute, once things actually have proved themselves a little bit, maybe there's a solution in here that we can use. Consultancies make a lot of money, essentially, being the people that do what's called bridging the gap, where effectively they look to what all the cool kids and the startups are all using, and they say, some of this technology has value, and we can go and essentially help enterprises transition to it. So things like the ThoughtWorks, Tech Radar, those kind of things. That's really about consultancies trying to sell you bridging the gap. These two graphs effectively can be aligned. So essentially the trough of disillusionment is really where effectively you're trying to cross the chasm. Okay, and I'd say, traditional C# is over here, and .NET Core is somewhere around here. So how do we cross the chasm? How do we convince people either to come back who've left, or to come to the platform essentially for the first time? And generally the model is the people come to use your particular toolkit from the other side of the chasm if they have a problem that is being solved. The majority of developers working in those kind of environments are very pragmatic. They're not going to go out and learn F# unless you demonstrate to them that they have a problem that F# will solve. For many of them, C# is good enough, and they're not going to go and say, I'm suddenly going to go to all the effort of becoming a functional programmer and doing F#, unless they have a problem today which you can demonstrate to them that essentially you are the solution to. They can't get around, or the workarounds in their existing language are problematic. And over time, you can see that the inflection points in technology often relate to paradigm shifts in our industry. So we basically go to Windows, effectively, and visual languages take off. Things like Visual Basic emerge. We go to the web, essentially, and then we get platforms like ASP.NET, Rails emerging eventually. Mobile comes along, essentially, and a whole new range of technologies get their day in the sun. Big data was one of the last ones. Today, I think the big inflection point we're dealing with, essentially, big paradigm shift is cloud native. So this is the move to infrastructure as a service, the move to containers, the move essentially to you effectively no longer dealing with infrastructure, essentially renting it, or even in the world of serverless, it disappearing from you, right? That is the next big new shift. And I think if .NET Core really wants to take off, what we have to understand is, does it help people dealing with that scenario? Because that's really the next pain point, right? Okay. We run on Unix, on .NET Core, right? I think that's become a bit of table stakes. I don't think it's anything else. I think you have to do this now because otherwise people are simply going to turn you away because you're limiting their options when it comes to deployment. The funny thing about running on Unix is the fact that you can do it is as important as whether you do it. It simply removes a barrier to the adoption of your framework and language, because people say, well, I could run on Unix. That's not a concern for me anymore. Okay. Scale to large code bases. I think one of the winning things about something like C#, and it also applies to some of the containers like Java, is that they are very good when your code increases in size or your development team scales and you have more developers working, because a number of the technologies they have, like static typing, generics, for link read, declarative stuff, where effectively you can write DSLs and be declarative, and emerging ideas like pattern matching mean that essentially you can begin to deal with greater complexity. And this is the point where people writing, for example, in Node.js begin to break down. You can see that trend almost effectively for those dynamic languages in the fact that things like TypeScript are doing so well, right? And as essentially it's trying to rewrite JavaScript to C#. Eventually the entire world will be C#, not JavaScript, in case you hadn't realized, because Anders will simply turn JavaScript into C#. The emergence of PEP 484 in Python is another one where essentially Guido's gone away and let you put optional typing hints in, because of the difficulty essentially of scaling on large code bases. I have no idea whether that's because he's working at, I think, Dropbox, and they've encountered that problem there in terms of the amount of code they have written in Python, right? So we already have those advantages. Parallelism and concurrency, right? Many languages do concurrency, less support parallelism. Okay, so Node.js gains very well from concurrency, and it uses the libov, basically a library, to do what's called a reactor pattern, essentially a message pump, which effectively lets it be very performant by yielding control when something is waiting for I/O. Okay, but that's not a Node.js thing, right? Any language can, in theory, support that same model, and C# does via async await. What's harder on those languages is they generally have a problem called the global interpreter lock, which means essentially they can't really do multi-threading because the interpreter is always effectively a bottleneck to it. And certainly in Python, if you want to do multi-threading, their threading library really actually is just essentially a library that supports basically being I/O bound, because the underlying C libraries that implement it yield control. And if you want to actually have parallelism, you have to use a multi-processing library. You have to fork new processes. Whereas C# has the TPL. TPL is a fantastic library, and not, I don't think, often shouted about enough how good a library that is essentially for doing parallelism. And I once was in a Java session where some guys were discussing, their dream parallelism library, and the guy was putting up his fantasy library requirements. And at the end, I was kind of like, well, he just described the TPL, right? We ought to make more about the TPL and how good it is. RX began on our platform, right? And that is everywhere now. So it's important to understand we have a solid platform on that. Performance, two things. Most of you have probably seen there's been a huge effort on performance. .NET was criticized in the past as being nowhere near as good, the TLR is nowhere near as good as the JVM in terms of perf. And while still there's a long way to catch up, this move towards removing excess allocations, etc., a lot of the work that's been going on has made .NET Core very performant. The other thing we have is unsafe. Do not underestimate that. Java, the JVM, etc., has no real equivalent via Java. And if you talk to people like Chris Condren or even Greg Young, who've worked on things where they need control of memory management, they write a lot of code using unsafe, right? Which is stuff that I understand most of us don't necessarily always need, but you can do some very interesting things. And in terms of our key things we want to talk about today, right, in terms of coming back, if you just look at some of the benchmark numbers, basically comparing .NET Core with Node.js today, you can see we are way more performant, right? We may not necessarily be beating the JVM or Go today, but in terms of that big competitor, we are certainly doing very well. And this is Martyn Thompson. Anyone know Martyn Thompson? Writes a blog called Mechanical Sympathy. He's pretty much the guy on performance on the JVM, and he has been consistently complimentary about what he sees as the effort going into the CLR in terms of performance, right? And other people noticing, right? People out there are beginning to notice essentially that the new platform is very performant. And if you went to Node.js because it had high throughput and was very performant, that is no longer really an argument. And you do see people actually being recaptured to ASP.NET. And that's your early target market, right? People who are familiar with C#, have .NET skills, and essentially people you want to bring back onto the platform to say the reasons you've left have gone away and actually were better now than what you're using today. And then once you begin to pull some of those people back, you need to then try and go to a new market. We're multi-platform, all right? And don't underestimate that. For smaller shops, this can be quite important, the fact that they can essentially have developers with a smaller skill set hit a wider range of targets. And we also shouldn't forget that the way that actually many youngsters encounter things like C# is actually through doing games programming in Unity, not through the route of doing business programming. And that's a really powerful way of getting people onto the platform. The other thing is, one of our strengths is that we do have a large talent pool, right? There are a lot of capable people. And one of the other things Twitter talked about when Twitter went from Rails to JVM was not just performance, but essentially its ability to hire large numbers of developers who had experience delivering apps working at scale, okay? And we are essentially a reason for businesses to target .NET, right? Experienced developers who know what they're doing, right? Who can therefore effectively give you some of that heavy lifting that you need. And C# is increasingly, when we hire graduates, right? And we find increasingly there are graduates who've done C#. Microsoft's made a really good effort at basically getting into the education sector so that you can hire people out of the gate for whom C# is not a mystery. Okay. What's the future look like? Okay, so the cloud shift is to cloud native. What does cloud native tend to mean? It means microservices, right? It means basically what we call 12-factor apps. Those are apps built to run basically in containerized or cloud environments. It means a self-service agile infrastructure that is essentially cloud and container environments. It means nowadays API first. We deal with mobile, we deal with essentially the same way we deal with web. API is really what you expose on the server. Anti-fragility, we won't talk about that today, but essentially that is chaos engineering, as in Netflix. So on the microservices, I'm not going to bore you and give you a long talk on microservices, but I think we can all probably agree it's decomposition of a monolithic business system and independently deployable services that do one thing. There are lots of various schools of thought on quite what that decomposition is, essentially. It's irrelevant today. So this is eShop containers. It's worth going to have a look. It's a really nice kind of project from Microsoft, some guys trying to basically provide an example of how you would do microservices in .NET with a kind of real world example. Okay. And you can see essentially the idea here that effectively we've got, say, Web API basically being exposed outside the data center, and we've got an event bus for communication internally, and you've got microservices written effectively in .NET Core, right? And we've also got a more traditional model where you've got an MVC app talking to basically a traditional web app. I don't think that's such an applicable story today. I love the MVC guys, but I think really you want to focus on API because probably over half your traffic's going to come from mobile, so you really need to focus on an API and building, say, your range of clients, both web and mobile, talking to that space. And we have a lot of good libraries basically to talk about in this space, right? So we've got .NET Core, obviously, Entity Framework, Nancy. We've effectively got Dapper as well as an alternative to Entity Framework Lightweight. There are tools for talking to Redis, like from Stack Exchange. There's Bright, which I work on, doing event bus stuff, on the end service bus and mass transit. If you want to do identity as well, it says identity is identity server. Identity server is one of those ones that's known outside our community for being a high-quality platform to doing that. And there's things like Service Stack for doing that overall end-to-end kind of service implementation. So we actually do have quite a lot of the OSS infrastructure you need today to build microservices, essentially. And you'll see also, notice that basically that the diagram shows it being hosted in Docker, all right? And hosting in Docker is one of those things that we're quite good at on .NET Core. And if you look at essentially the workflow, what tends to happen with something like Docker is, when you build, you essentially build and compile, you do a restore effectively of your code within the container. So that means that essentially I create a simple container that just has the runtime, it's quite lightweight. I then essentially share my local directory with the container, or effectively I then do a .NET restore, and that pulls down just what I need, right? And then essentially I do a build, potentially a publish, or do a publish effectively. And the advantage of that build model is that I can be sure of managing my dependency chain. I don't have these kind of globalized dependency issues. So it's very powerful effectively for working with Docker. API first. Right, the modern model is basically we focus on the API as the point. What's really interesting here is that you get this idea effectively quite often of API gateways. So rather than exposing my microservice directly out to my customers, because then I couple my microservices, I quite often have this intermediary called an API gateway, right? You talk to the API gateway, it's kind of an anti-corruption layer, and that means I can verify my back-end microservices without necessarily breaking any of my existing clients. I can also find that I can avoid chatty calls, because sometimes actually to service the request from the client, I may need to make 3 or 4 calls basically on the back end, and it's much easier in terms of latency to make that call from inside my server environment, making a call across, composing there, and then returning the composed result back out. And where today you get guys basically in the client making 4 or 5 calls and combining the results, under this kind of model, you just shift that code up to the server. But what that tends to mean is that this thing called a back end for front end, BFF is what Sam Neiman calls them, which basically a part of this idea of an API gateway that will effectively call your microservices on behalf of the client. They're quite often written in the same language as the client, because they're quite often authored by the client developer. Rather than making the calls locally, the client was just making them on the server to reduce latency. And I would argue, therefore, you're quite often going to find, even in this environment, that that's actually going to be something like Node.js, right? You shouldn't necessarily try and target owning that space. Let the Node.js guys have that. Write your microservices in C#. Target that initially as being the sweet spot for where we have lots of advantages in terms of managing code bases, in terms of performance over that. Now, admittedly, if what you're talking to as a client is desktop, or mobile written in Xamarin, yeah, absolutely. You want to basically be able to write the BFF and something like ASP.NET Core because those guys, their language is C#, and they want to basically hop onto the server and write C#, right? The other thing to be aware of course, is that because we're a microservices platform, we can write those services in multiple different languages. So be prepared for a future in which you are polyglot, right? Because you may want to use Python for data. And right now, at Huddle, we talk about people knowing Python, JavaScript, and C#, right? And that's not necessarily an unreasonable expectation. So if today what your dream is as a server developer, I'm just going to be C# everywhere, that's probably not a dream to hold on to. The other part of API gateways are effectively perimeter concerns, things like rate limiting, HTTPS termination, seek cause, IP restriction, authentication, APM. There are a couple of ways of doing this. One is essentially that you just get something like OpenResty built on top of Nginx. Use something like Kong to do that if you want to. Tons of Lua scripts, essentially, and you do all of it effectively in your reverse proxy. The other option, effectively, is to build that into each one of your libraries. There are pros and cons to each approach. Putting into all of your basically microservices effectively means they have to be very concerned with things that aren't necessarily what the microservice has to deliver. But if you don't want to have to go to building an API gateway, which might be a bit much for you at the beginning, it can be handy to have that option of starting out by putting those concerns into your microservices and later on building out an API gateway, because they can be expensive. Mostly you don't care too much about this particular story, apart from the fact that you need to support it. So in cloud native, essentially, we're moving away from this kind of DevOpsy model. It turns out what happened, as far as I can tell, is that the developers got involved in operations when DevOps came along. Developers said, wow, there's a lot of work here, guys, that you're all doing by hand. Really, we should just automate this out of existence because we're all pretty lazy. Developers tend to be lazy, right? And so good developers anyway. And so they said, well, let's just automate this whole thing out of existence. So over time, what's happened is we've moved to declarative models like Docker Compose files. And really, we're approaching this point where, as developers, we just want to say, I want to have a RabbitMQ box, a Redux box, 2 worker boxes, 3 web boxes. I can put that into a file, and I will just simply let the infrastructure provide that via. And things like Azure, AWS, have these kind of do that for you, right? I just give you container definitions, you spin out the boxes for me, and the problem goes away. And serverless is kind of, if you like, the ultimate point in that journey, right? Where we essentially say, actually, you care so little about what is hosting the CLR that essentially I can hide it from you. At a certain point, once you start dealing with things like containers and serverless, you actually stop worrying what the underlying operating system is because you just don't really deal with it. You deal with the runtime. And so that's the growth of things like Docker, that's the growth of things essentially like Azure Service Fabric, right? The platform as a service environment. Interestingly, Microsoft came out with the paths first on Azure, kind of went too early, but the growth effectively of platform as a service environments, which handle all that hosting concern for you. The growth of things like basically Azure Functions and basically AWS Lambda, where essentially, again, I don't care about the container environment that I'm running on, right? So .NET Core is responsible for you being able to run in AWS Lambda, right? Because it's a cross-platform. So it's no longer caring. AWS is not being prevented from you doing that. It's probably one from Google as well, isn't there, John? I can't remember his name. There you go. Cloud Functions from John and Google. There you go. 12-factor apps. 12-factor apps, again, right? I do another talk on this. You can probably find it online. I think I gave quite easily about quite what they are. But 12-factor apps are really a set of guidelines you should follow for building your apps basically to run cloud natively. And I don't want to run through what those properties are. As I say, just search for me and you can find me talking about it in videos online. But what I wanted to call out is that we actually have quite good support in .NET Core for some of these scenarios, right? The way that .NET Core's, particularly its command line infrastructure has been engineered, supports this model quite well. So for example, you want to basically say, I only want the runtime and language installed. I want a file that says where are all my basic dependencies, and I want to be able to restore them. So basically, you can do that from your chproj file via NuGet. Store config in the environment, right? So basically, we're trying to move away from these model of generating templates that essentially insert the variables and adding configs across the board via some curious build process that's basically mostly templating, and actually say, well, things that vary by environment can live in environment variables or in a configuration server. And you'll note that the new configuration model within .NET Core supports things like basically putting them in environment variables and has a progression which lets you essentially say, well, it may be in the web.config, but I may have overridden that with an environment variable in the given environment. We basically want to have this separation of these individual phases to allow us to more clearly automate the process, and we do have that within .NET. We want to basically have self-hosted services that basically simply bind to ports. And under .NET Core, you've got things like Kestrel, you run self-hostedly. It's very difficult if you want to basically run in a Docker container to put IIS, which is an application container, inside every Docker container, right? You don't want to do that. So essentially, your model is much that you want these microservices to be self-hosted, expose a port, and then use something else as a reverse proxy like Nginx. Or you could use IIS as a reverse proxy if you were just, feeling difficult yourself. It also talks about essentially saying all of your admin code, the code that essentially lets you do things to maintain and look after your app, should actually be shipped with your application. And the CLI stuff around .NET is really powerful tooling for us to essentially automate basically those processes. Okay. So I'm going to give you a little bit of a model of kind of how I see the future, right? So I don't know if you know this is Simon Wardley's model, which talks about there being pioneers, settlers, and town planners. Pioneers are the guys that go out and build the MVP. We don't know what the customer wants. We're going to try something. Settlers are the people that say, oh my God, it took off, let's scale it. And town planners are the people saying everything is kind of like mature, let's maintain it. I would suggest that we are still probably in a world where we let those guys target basically early versions, and we really want to target C-sharp's strength as being when you come in as the settlers and town planners saying, that was a great idea, let us take over. So, you're not necessarily trying to kill Node.js out of the environment whatsoever at all. You're trying to say essentially we can coexist because there are things you do badly and we can help with. And you're likely to find that you're going to enter an environment where there's been a monolith written in Node.js or Ruby or Django in Python, and what you're trying to do is then decompose that into basically microservices written in C#. I don't think necessarily you want at this point to try tackling being the people building the microservice again. Oh, and you can basically do other things. Quick shopping list. I may get through this pretty fast. There are a number of things out there we might want to think about building. And there's plenty of opportunity, essentially, within the .NET open source space for people to make their mark. These are all the kind of things that you need to have in order to build a rich microservice infrastructure. And we can use tools built in other languages in some of these cases, but it would be useful to have some of these. Particular ones I want to call out are things like templates and wizards, basically for microservice environments. So setting up basically the basic template for, I want to use these particular pieces of kit, can you basically set me up the basic project infrastructure and whatever? So equivalents of drop wizard. Configuration servers, you could use things like console and vault, but it might be interesting to actually figure out whether we could do something useful effectively in .NET around those. And supervisor workers, we could use supervised in order to get this done, but maybe we want to basically have something that works cross-platform. Top shelf Windows services, they're not cross-platform. So what's our future going to be? We're just going to use supervised, or we're going to do something else? Okay, community. I want to catch this one quite fast. I've got a few minutes. Right, so if we are resetting the community around .NET Core, I think we want to basically make a few changes as we go through. The thing is, right, any community needs to constantly invent itself, because all communities are like leaky buckets. People leave, and eventually the bucket will run dry. And we have a big bucket in C#. There are lots of, millions of developers, but eventually we will run dry. And you can't really plug these holes. People will always leave, so you have to refill the bucket. And if we don't refill the bucket, the danger is essentially we become an echo chamber, right? The same people touting the same ideas with no new inspiration. And even worse, what happens is some of these people essentially provide a barrier to interest of new entrants, because what they say is, no, we are the established people, we are the authority, we say how you do stuff, right? You can't get in, you haven't paid your dues, my God, you don't even know what WCF is, there's no way you could contribute towards our community, right? And we have to really break down that barrier to encouraging and welcoming new entrants and giving them their chance to make the mark. I have a personal thing is we need to get out of Slack, right? Slack is not public, it's not discoverable. We need to be having the conversation in places that are accessible. Developers look like this, in case you didn't know, right? Not like this room, sadly. We need to have a community that basically looks like this. I would call out the Python community, who are always very self-effacing about their efforts, but I believe that one of the reasons Python has grown is it has prioritized the diversity of its community as being important to it. And it welcomes developers of all ranges, including hobbyists. There are a wide range of C# developers, and one of the things we often get accused of is being derpy, right? But actually, you know what? We should embrace the badge of being wide-ranging in terms of interest and ability levels, and not be elitist, because elitist puts people off and drives them away from our community, right? Someone's talked about re-raising alt.net. It's divisive in the US as a moniker, but what we care about is the fact that in the Europe particularly, alt.net became a moniker for people holding meetups, etc., whether it's participation rather than basically someone lecturing to you. And the reason we want to bring that back is that feel that you can go to a meetup where essentially you are sharing with peers, not simply being lectured at. Okay? Because ultimately, if we are going to have any kind of renaissance, it is not going to be me that essentially creates it on my own, right? It's not with the guys on the ASP.NET team. They're lovely guys, but there are only so many of them, and they can't do it all. The people that will create a .NET Renaissance is you. You have to do it. If you want this to happen, you have to participate, right? And you have to bring others into participation in the community. We can do it, but we can do it, right? Not I can do it, and not Microsoft can do it. You have to be there. We need some people to come forward as kind of like to be heroes, right, for our community at this point in time, and actually say, we want change, right? We want basically a better community than we had yesterday. And I think that's very doable. I think, you know, I have been continually inspired at periods of time in my history by the .NET community. We've done some very powerful things together. I think energy levels are have come a bit low. And I think now is a time for us to kind of step up and say, let's talk about how we make our community more diverse. Let's talk about how we get new entrants. Let's talk about how we become the community that's known for being very, very open. Okay. That's me. Thanks very much. Please don't forget to vote. And please do comment on Twitter. I'd love to see a conversation about how we do this. I do not have all the answers, and you guys certainly may have very good answers you should share. Thanks very much.